Okay, so here's the key for practice exam 2. Come on. All right, so for problem 16, find the exact values of a, b, c, and d in the form a cosine bx minus c plus d. So we'll start by collecting our range. It looks like this thing has a minimum value of -5 and a maximum value up here at 1, or at -1. So -5 to -1 be our range. Next, we want to get that period. Look at the distance between these 2 points. So pi over 4 minus -5 pi over 12. I believe that works out to 2 pi over 3. That'll be 3 pi over 12 plus 5 pi over 12. 8 pi over 12 is 2 pi over 3. So 2 pi over 3. Next, we want an amplitude and a vertical shift. And that amplitude that'll be a -1 minus -5 divided by 2. Works out to 4 over 2, which is +2. The vertical shift, this will be -1 plus a -5, or just -1 minus 5, and that works out to be -3. All right. Next, we'll pick a phase shift, and this is a graph of cosine. Oh, which means we need to pick a phase shift that's either at a maximum or a minimum. So I'll probably choose this point over here, pi over 4. But other options for the phase shift would have been -5 pi over 12 or -pi over 12. All right, but now that we have all of that information together, we can get A, B, C, and D. Based on my choice of the phase shift, A is going to be a positive value because it starts at a maximum. So A should be +2. Then we want B. It'll be 2 pi divided by the period, which is 2 pi over 3, which should simplify to 3. We can just get the vertical shift. So -3 just has the same value as D and the vertical shift are always the same. So the only thing we're missing is C, which C should be B multiplied by the phase shift. So 3 pi over 4. So the last thing we have to do is just put that into an equation. 2 cosine of 3x minus 3 pi over 4 minus 3. Problem 3. Which of the following is the best graph for y equals 9 sine of pi over 2x minus 6? So, just kind of glancing through these, A is a positive number, so I'm looking at positive sign, and this option has a negative A value. A is negative, so that one's out. Next, D is going to be out because our vertical shift should be negative, but this one has a positive value for D, so that one's out. Sort of roughly getting at these. Then the next two, I could also rule out C because the vertical shift was bigger than the amplitude. So that guy is just too far away. So the one that makes sense is going to be B. Yeah, I will be posting this video to D2L later. It'll end up in the practice exam section. So yeah, we're actually recording right now. All right, which of the following is the best function for the graph shown? Well, we're looking at a graph of negative sign, which means right away we can get rid of all of those options because A should be negative. So now we have to decide what our value of B should be. Pi over 5 or 5 over 2. So looks like our period is 4 pi over 5, which means that B is 2 pi divided by 4 pi over 5, which simplifies to 5 over 2. So D. Right. So problem 5, list all the phase shifts where the value of A is positive in the equation f of x is A cosine bx minus c plus d. So we're looking at positive, and we're looking at cosine, which means those 2 points are our 2 potential phase shifts in this graph that have a positive A value. So negative 5 pi over 12 and pi over 4. All right, then we want to list all phase shifts where the value of A is negative in a sine equation. So because it was cosine, yes, I wanted the maximums. So positive does mean I'm looking at the maximums. If it were negative in cosine, I'd be looking at the minimums. So for sine, that's what we're looking at in problem 6. So it's worth noting in this graph, D is equal to -1. So there's our vertical shift drawn in. And that's where we're going to look for phase shifts for sine. And we're looking at negative a values for sine, which means at that point and that point. So this point out here is at negative pi, and this one's at pi over 2. So negative pi and pi over 2. So if this read that a was positive, I know how to spell positive, I would choose negative pi over 4. Very funny. All right, then in this next problem, I don't think the problem numbers are consecutive or anything. This practice exam was sort of Frankenstein together. Uh, this time we'll be doing the other direction, going from a function to a graph instead of graph to function. So show as much work as we need. So, well, the amplitude is the easy one. It's just 7. We take the absolute value if we needed to, but we don't. So it's just going to be 7. That period should be 2 pi divided by b, which is 2 pi over 6. So pi over 3. That phase shift is c over b. So negative pi divided by 6. Keeping in mind that c is negative pi. All right, then we want our range. We'll start by finding our maximum and minimum. So 7 and negative 7, both of those minus 3, gives us 4 and negative 10. Yep, correct. So generally speaking, in our, let's see, I've got the equation written around here somewhere. Yeah, it's up here. So inside our formula, it's always bx minus c. So c always has the opposite sign of whatever we see inside the function. All right, lastly, we wanted the x scale. So our period is pi over 3, so we want pi over 3 over 4, which is pi over 12. And we'll use all of this information to plot ourselves a function. So our come back up and grab our phase shift real quick. It's negative pi over 6. So we're going to move over to the left and have negative 2 pi over 12, since that's pi over 6. Oop. Pretty sure I've been marking that in magenta. Negative 2 pi over 12. Same as negative pi over 6. And then I'll need to count out 4 more tick marks. 1, 2, 3, 4. And count by pi over 12s. So negative pi over 12, 0, positive pi over 12, 2 pi over 12. And then across our, what are we going to end up needing? Actually move all of these guys up just a little. So marking our y-axis, we'll have a point down here at negative 10. Say negative 3 is about right there, and 4 is maybe about there. Ish. Give that a shot. So this was 4. This is negative 10. 4. And I'm also going to put in that center line at negative 3. Just to kind of help us draw that graph a little bit easier. And then we just have to plot our points. I think 4 is up a little high. Let's bring it down a bit. Okay, so we have a graph of positive sign. Up here, positive sign. So we should start our graph at the center and then move up. So middle, top, middle, bottom, middle. And then connect our dots. And then we can label all of our points. Negative pi over 6, negative 3, negative pi over 12, 4, 0, negative 3, pi over 12, negative 10, and pi over 6, negative 3. And that's our graph of sine. Oh yeah. And then trig identities are next. So let's start by just simplifying as much as we can on this first one. So I'll start by getting rid of any extra angles, getting rid of those negatives. Hopefully something will shake out of all this. So cosecant of pi over 2 minus theta is secant theta times cosine of negative theta is cosine of positive theta. Next up, tangent of negative theta is going to be negative tangent theta, and tangent of pi over 2 minus theta is cotangent theta. Okay, so for anybody watching the video later, Will the exam be mostly graphing like this practice exam, or will there be more trig identities on the actual exam? The split's going to be pretty close to what this practice exam looks like. It's about 3/4 graphing, 1/4 trig identities. Yeah. Right, so we were continuing on with this mess up here. Secant of theta is 1 over cosine theta. Times cosine theta minus tangent theta, and cotangent theta is 1 over tangent theta. Which, since I'm running out of space, I'll just move over to the right. That's going to be 1 minus 1, which is 0. So we'll go check our matching section. Hopefully there's a 0 option. There is. Made it convenient and called it O. Actually kind of looks like they're backwards. Looks like I said that 0 is O. Yeah, whatever. Either way, I think that comes out just fine. Yes, exam opens Thursday, so tomorrow. All right, on to that next one. Our numerator, secant squared minus tangent squared, that's a Pythagorean identity. It's just 1. And that denominator, 1 plus cotangent squared, is also an identity. That's cosecant squared. And 1 over cosecant is sine. So 1 over cosecant squared is sine squared. Yes, the exam is open until Sunday at 11 p.m. So hopefully there's an option for sine squared somewhere in the box. And there is. So H. All right. And then for the last one, secant of negative theta times tangent of pi over 2 minus theta. Secant's even, so secant of negative theta is just secant theta. Tangent of pi over 2 minus theta is cotangent theta. If we change all that to sines and cosines, 1 over cosine theta times cosine theta over sine theta. That'll just simplify to 1 over sine theta, which is cosecant theta. So option E. So secant and tangent are not on this exam. That'll be worksheet 8. The secant, tangent, cosecant, cotangent. So it's just graphs of sine and cosine. So the worksheets covered on the exam will be worksheets 5, 6, and 7. So they're already grouped in D2L under exam 2 content. I've reorganized that a little bit. All right. So in problem 10, we get a bunch of fun stuff. So starting with that secant squared minus tangent squared. That's a Pythagorean identity. It is equal to 1 plus tangent x divided by cosecant of pi over 2 minus x. That's going to be equal to secant x. Plus, over on the other side, cosine of negative x is just cosine of x. Because cosine is even, but cotangent is odd. So that'll be negative cotangent x. So all those pieces in green are the steps I changed in that first go round. All right, then let's reorganize a couple of pieces. 1 over secant is the same as just multiplying by cosine. Times 1 plus tangent plus, oh wait, this will be minus on the other side, cosine x times tangent x, since that's the reciprocal of cotangent. So it's cosine and secant are the two even functions. So they're the ones where a negative x doesn't matter. So we maybe multiply some of this stuff through. This will be cosine x plus cosine x tangent x minus cosine x tangent x. And here we're basically done, right? Because that and that add to 0. So we're just left with cosine x. Right, and then we're gonna do problem 1 again, and just maybe this time pick a different phase shift. So let's do it. I usually start by finding the range. So to get the range, I'm looking at my maximum and my minimum y values, which are here and here, because that's as far up as that function goes. So my range should be -5 to -1. So I always want to list the minimum point first. Next, if we're looking at that period, it's going to be that distance between, two maximums or between two minimums. And if I count the number of boxes, there are 1, 2, 3, 4, 5, 6, 7, 8 boxes in between that maximum and that other maximum. And each box has a width of pi over 12. So that period is going to be 8 boxes with a width of pi over 12. 8 over 12 simplifies to 2 over 3. So 2 pi over 3 for the period. Scooch that up a little bit. Next we can get the amplitude. And that amplitude should be -1 minus -5 divided by 2, which is 4 over 2, or just 2. Then that vertical shift, it's going to be a relatively similar setup. -1 plus -5 over 2 is -6 over 2, or -3. And then for the phase shift, pick a different one from the first time we did the problem. I'll choose this point because I must pick something for cosine. And that phase shift is at an x value of -pi over 12. So those equations for amplitude and vertical shift are listed on worksheet 7. Oh. Yeah, it's on worksheet 7. Had to stop and think there for a minute, but that's where it is. Right, next we got all 5 of the pieces that we needed to read from the graph. So now we have to turn that into values of A, B, C, and D. Now because I chose a phase shift that started at a minimum value, I know that A needs to be negative this time. So -2 for A. Likewise, I can just fill in the vertical shift. It's -3. There's no real work to show for that. D and the vertical shift are the same. Also, I need to get B and C next. B, I think I usually do in red. So B is going to be 2 pi over the period, which is 2 pi over 2 pi over 3. And that's 3. And then C is equal to B multiplied by the phase shift, which is 3 times -pi over 12, which simplifies to -pi over 4. So the last step is to just put all of that into a function. So -2 cosine of 3x minus a negative pi over 4, which means it ends up being plus pi over 4 minus 3.